Well, hello everyone, and welcome back to Adrian's Digital Basement. It's Wednesday, so you know what that means. It's time for another midweek mini mail call. We're actually up to number 34, which is simply amazing. I say that every time, and I sound like a broken record, and I do apologize for that, but it still amazes me how generous my viewers are sending in so many incredible things. So anyhow, without further ado, let's get right to it. All right, so we have one here, and this comes from Jeff Birt from the Hey Birt channel. If you aren't familiar with his YouTube channel, I'll put a link in the description, so check that out. He makes all sorts of cool parts for the 64, like case repair parts. He has sent something into the channel before for repairing your 64 case when you have cracked hinges or clasps. And I know what this is. He has told me about this ahead of time. In fact, he has made a video on his channel about it. But he has sent some to me so I can show them off to my viewers. All right, so the note is just an email he sent to me, so we were talking on email. What he has gone ahead and done, and I'll link to his video, is he has worked with a supplier in China, I think, to manufacture some new Amiga video connectors. These are 23-pin D-sub connectors, and they haven't been made in a long time. Commodore picked a slightly unusual shape so you wouldn't accidentally plug your printer into the video port because there's 12 volts and stuff on here. And when these went out of production, it becomes really hard to find them. And a few years ago, you could still buy these, not super cheap, but they weren't that expensive. But Jeff told me that they are now really hard to find. Anyways, okay, so besides these 23-pin connectors, he has sent Amiga 1200 and 600 case saver kits. And there's some really tiny things in here. This is the Lapse printer plotter mechanism brass pinion gears. Tiny little gears. So we'll take a look at that in a second too. I don't actually have a printer that would go with that. He has some reproduction C64 rubber feet. And right here, this is also interesting. 8701 Hey Birt edition. So this is the clock generator chip, and we'll take a look at this close up as well. It looks very small. Okay, well, let's take a look at this stuff on the bench. All right, here is the care package from Jeff, and he sent me this lengthy letter here. So let's see, in this package, we have the brand new DB23 F female, that is, video connectors. Now, I recommend, if you don't know who Jeff is, check out his YouTube channel. He's got one where he does 64 repairs and whatnot, but he's really well known for making case repair parts to fix your old bread bins and other broken retro computers where the cases are falling apart. He has all sorts of repair pins. Well, he had a video recently where he went out and had these hard to find, basically impossible to find, Commodore Amiga video connectors. This is what you need to make a video cable or device that plugs into the Amiga's analog RGB video output port. Well, actually, there's digital analog, or there's digital RGB on there as well. So he has gone ahead and sent me two. Now, there is no shroud, I notice here, like there's no, the plastic casing that goes around this, but that is probably something you can 3D print. He doesn't say that in here in the letter, but I am pretty sure that if you go on Thingiverse, someone has already designed the housing for this. So he probably didn't bother having those made, just getting these connectors made. It's rather interesting to watch his video. He talks about the process involved with working with manufacturers in China and picking out all the different types of contacts inside for quality levels and stuff. So rest assured that he has made these to the exact specification that Commodore made theirs for and used high quality contacts. So if you use these to make cables or whatever, they should be nice and high quality. Next up, he has included a MOS 8701 Hey Birt edition, which is the C64 C128 clock chip replacement. So let's cut open this bag here. It is in here. So this chip is fundamental and absolutely required for your C64, that is the newer version of the motherboard, and also the 64Cs with the short board. Some of the long boards have it as well. And also the C128, it requires this chip to generate the clock signals. Originally, there was a bunch of discrete electronics on the 64 that did the job of this little IC here. Oh boy, I'm looking at this. This thing is tiny and I'm really struggling to get it out. There we go. And there it is. So as he mentions here in his letter, it was originally Frank's IZ8 DWF design. I've talked about him on my channel plenty of times. Check out Frank's channel if you haven't already. I think he designed the original one. And Jeff just modified this by adding a tiny inverter so it auto-configures to NTSC or PAL, like the original chip. Yes, the original chip doesn't require any kind of jumper. You just put it in the appropriate machine. And interesting is he wanted to keep the package absolutely tiny. And so he used these crazy Z-bend pins here, which look like they're normal pins, but he bent them like this and like that in the shape of a Z, I guess. He must use a jig to bend the pins to be able to fit on this and fit within the socket on the motherboard. So that's pretty cool. He's got a link here to the assembly instructions, and you can buy this as a kit or assemble and or test it. If your machine that uses an 8701 could be also labeled 7501, if that chip dies, you get a black screen and you get no clock signals. You can check with an oscilloscope or even a logic probe on the clock pins and you won't have a clock signal when this chip is bad, and you will need a replacement. And the original Commodore chips are very hard to find these days, if not impossible. So it's good that these alternatives exist. He's also sent in some Amiga 1200 and 600 case saver kits, which are these little things here. Looks 3D printed. Now, I don't have a 600 or a 1200, so I don't, of course, have a case where these are broken, but let's just pop these out of the bag here. Test fit the rear clips first. If you have clearance issues with floppy drive, use 2 clips without wings on the side. And for best results, we recommend DevCon 22045 plastic welder or JB Weld plastic bonder. I love JB Weld. I would be using that. Let's just check these out. Okay, so he has 2 types, one with wings and one without wings. So there's one with wings and there's no wings. So yeah, I guess you just have to use the appropriate one on your machine. And I am sure that he has a video on his channel on how to install these. And look, there it is, installation video right there. Jeff is pretty funny. He writes, I know you're not fond of the Amiga 600, but you never know. It might grow on you and you have the case saver kit. So that's funny. Yeah, I mean, I have Amiga 500s and I have 4000 and I have Amiga 2000. I feel like the 600 is kind of redundant and the 1200 is a bit redundant as well because I have a 4000. So what does the 1200 do that the 4000 doesn't, right? And then next he has sent me right here, which are C64 rubber feet. Nothing special, just the rubber feet. I needed several, so I bought a bunch from the manufacturer. Well, that's pretty cool. Hopefully you can buy these directly from Jeff as well. But that's pretty handy because what do I use for my 64s? I think I use these. I bought these. Are these even the same size? It's hard to tell. They might be a little bigger. These things are strange. It's going to be hard to see, but they have like little, they're soft rubber, the whole thing, but it has these little nub parts here, which when you put it down, it's kind of extra shaky. So I actually usually put the foot on and then I cut off this middle rubber, which when I do that, it just leaves the rubber foot, and they're very grippy. And I find that they work. I got these from AliExpress ages ago. I bought a bunch of different feet at the same time. They were all terrible, almost all of them, like hard and really gummy adhesive, so they would fall off and just junk. These are the only ones that actually seem to be good. It says 3M, it's probably fake, but they're not bad. But anyhow, it's nice that Jeff has sent me one set of actual feet because yeah, a bunch of my bread bins are missing their feet. And I think I've stuck on stuff like this or who knows what. Okay, so yeah, so the ZIF 64, it does have these. These ones are in these 2 holes right here. And then these look like maybe original feet. I don't remember. But yeah, so okay, good to know that these cheapy ones, they do fit in the bread bins. And I think that's what I end up putting on most of the machines now are these. Even though they're not original, it works fine for me. And lastly, he sent these little metal gears, which are the printer plotter mechanism brass pinion gears. Seem to have been used on dozens of different brands, I guess, sold the same Alps mechanism printer, and these are the gears they must strip. The biggest failure point is the pinion gears. I finally found a manufacturer that could make new ones out of brass at a reasonable price. It has been a treat to see folks being able to get their printers working again with a new set of gears. Of course, if they were plastic, the originals, they would strip and be horrible, but these brass ones should last you a nice long time. Now, of course, he has a video on that, installation video. I'll put a link in the description of that. And I don't have one of these Alps printers, so I'm not a big printer guy. I like dot matrix printers, and I have a few, but I mean, just a couple. I think I have a Tandy printer, and I have a Star Micronics, and that's it. Don't have any others. And plotters and things like that, I'm not a big fan of those. I just, yeah, I don't know. Something about the 9-pin dot matrix, that's the sweet spot for me. And honestly, you know, I have one that works on pretty much most computers, so I don't need to have a whole bunch of them, and they're kind of big and they require ink and anyways. But if you do have a fondness for these pen plotter things and you need to replace a gear, well, Jeff's got you covered. So very cool, some neat stuff here, especially the fact that there's a fresh supply of these Amiga video connectors and a way to fix your Alps printers. That's amazing. And these case saver kits that Jeff designed too, very handy. So like I mentioned, I'll put links to the various items in the description below, installation videos and stuff like that. And then I'll put a link to Jeff's website. I think you can buy all of this stuff there. So yeah, thank you very much, Jeff, for sending this stuff in, especially this 8701. I don't have a computer right now that's got a broken one, but I am sure it's only a matter of time. Before I open the next package, I want to say that I use this remote for my camera. It's made by JJC. It's for the Sony cameras. I guess it works on a lot of them. Don't buy this. Do not buy this product. It is a piece of garbage. It is so unreliable. It's so hard to get working. I should have spent the money on the real Sony remote, which I think was kind of expensive, like $50. But to be honest, I don't remember how much I paid for this thing. I think it was like $12, which was $12 too much. I basically took my $12 and lit it on fire. And I should have just bought the real thing from Sony because I hate using this remote. Oh, I can't even talk about how frustrating this thing is. And there were lots of comments talking about how bad this was, but there were lots of comments saying how good it was, which were probably fake comments. And all the real ones where people were complaining about this were the ones who actually tried this thing, and it just doesn't work reliably. Anyhow, okay, next package here. This comes from Italy, actually, and it says ITACA Innovations, SRI. So it looks like a company. Adrian's Digital Basement. So that's cool. Hi to all my Italian viewers. I might have talked about this on the channel before, but I was lucky enough to go to Italy, spent some time in Venice, Florence, and also Rome. And I just had an amazing trip. It was a wonderful trip. There were a lot of tourists. I mean, that's the one negative of the places we went in Italy, because obviously they were the tourist destinations. And I would have really preferred to have gone off the beaten path a little bit. But anyhow, took the train around the country, just stunning, great food, you know, all the things that people say about Italy. I had a great time in Venice. Look, I managed to get away from the crazy crowds and, you know, kind of go off the beaten track on foot and just walk around and explore that city. I was really happy to have Google Maps, though, on my phone because that made navigating quite easy. It's amazing how well that works. Without that, would have been really hard. So anyhow, let's take a look at what this is here. So it says Simple VGA Console Manual. Interesting. Okay. So we got a bunch of stuff in here. Yeah, no letter. It just says Simple VGA Console, which appears to be a kit. So there's a PCB here. We have some parts, and it looks like perhaps it's a serial console. And in here is a little tiny, it looks like a little tiny microcontroller of some kind. A couple cables, and there's a manual, and there's another manual here. So yeah, let's take a look at this on the bench. So the microchip Simple VGA Console. Let's take a look. Thank you for choosing ITACA Innovation. So I'll put a URL in the description below so you can check that out. There's a copy of the PCB. And here are all the various parts that need to be soldered on. Do not solder it directly. Solder the IC socket first and respect the correct orientation. And we have a small manual, and the font is tiny. Thank you for buying Microchip Simple VGA Console. This open source project allows you to play and create simple video games using a VGA monitor and a USB gamepad or keyboard. In this document, we show you details, suggestion, blah, blah, blah. The micro SD card must be formatted FAT32, 5-volt power supply, has audio and VGA, and has a little schematic. I'm sure this can be found online, open source hardware logo. Here's a bit more on the installation. All right, well, yeah, pretty simple. I guess let me pull everything out of the box here and put this thing together. So let's see, in this little thing here is the actual microcontroller, or whatever this is. Maybe it's an FPGA. It's very small. This is obviously the brains of the operation. And there it is, this thing is tiny. I see Atmel. I can't really make out the rest of the markings on there. Pretty densely packed little device there. The PCB, and how nice. The one surface mount component, which is the SD card slot, has already been attached. And look, a 16 gigabyte card in here. That's awesome. All right, then we have some various passives, crystal oscillator, and this is probably that 74 ACT chip there, like a bus transceiver. And in the other bag here, we have the VGA connector, various components, a few screws, the IC socket we need, some standoffs, LEDs, things like that. Also included was a USB cable, just a standard A to B USB 1.1 or 2.0. Right here we have a cable that is USB micro to a female regular USB-A, which I assume is USB on the go for connecting right here to this little, the brains of the operation. I'm assuming this is where the keyboard or game controller plugs in. All right, I'm gonna assemble this with some time-lapse soldering. There's not really too much to assembling kits like this. The way I go about it is I organize all the parts first, especially the resistors. You want to probably organize them and then check the value of each with a multimeter. And what I'm doing here is I write it onto a little box after taping them to the box, and I write the values. And that way, when you follow the BOM or the parts material list, you can just kind of go down the list and it says resistor here, resistor there. You just grab the right values, stick it on the board, and then you check it off on the little paper. That's what I'm doing here. And then I'm using blue painter's tape to cover up all the components as I flip them over on my little jig assembly thing here for soldering. There are lots of different ways to do this, but I find the painter's tape actually works pretty well. You can go about soldering all the parts on, clipping the leads off, and you just keep going down the list. Of course, you start with the smallest physical height components first. So I started with the resistors, and then I'm working on the capacitors next, and actually just some of the other random parts. Blue painter's tape again does the trick. And the last few components, like the VGA connector and the two little pin headers for the main brains of the operation. And I just stick the little brains of the operation into the pin headers just to make sure when I solder them on that they are aligned properly. But after putting two pins on, I pull it off so I can solder the rest of them, just in case, I don't know, transfers heat into the little mini PCB with the microcontroller on it. And there we go, it's all assembled. It wasn't too difficult. I did substitute, there was a red and a yellow LED. I put green as power, I had one in stock, and yellow as SD, and I'm... Okay, so I don't have the little brains of the operation or the SD card installed. Let's plug in the USB power. All right, so there's a green LED that's lit very dimly. I guess I maybe should have used a brighter LED or maybe a different resistor value, but that means it's getting power, so that's a good thing. So I'm gonna plug in the brains of the operation in here. There it goes. All right, I have it connected to this VGA CRT. USB power goes off to a power supply. I have the USB on the go connector here. and is connected into this USB-I Buffalo USB game controller. I put the included SD card in here. So let's see if this thing works. Plug in the power supply. Yes, there we go. Turn down the brightness on the CRT. Check this out. uService Game Loader 0.1. This is just one of one pages. Let's see here, 8x8 sprite demo. I'm not sure which button actually starts the game here. It doesn't seem to be any of them. Start select. I wonder if this needs an Xbox controller. Why don't I try a USB keyboard? This is one from an iMac. See if this one works any better. Well, the keyboard's not doing anything right now, so I'm going to push this white button here, which I assume is reset, and it looks like it is. Yes, and this keyboard, it's not working at all. Now, I wonder if it's not working because this keyboard has a built-in USB hub. I think the keyboard itself is connected through the hub, which this thing may not be enumerating properly. So I'm just going to try a different USB keyboard. Okay, so here we are with an HP USB keyboard, and it does work. All right, we have some demos and stuff on here. 8x8 sprites, 66 sprites move around in an animated background. So if I hit enter on that, there it is. Nice and smooth too, looks like 60 frames per second. Sprite 16 is 28 sprites moving around on a scrolling background. I assume it's different resolution sprites, and there it is. These are the sprites here, and that's the background, and again, nice and smooth. Here's a horse one, demo showing the most nice features of the 4 bits per pixel mode. And it doesn't seem to do anything. I'm gonna power cycle the whole thing again. Definitely boots right back up every time. Horse. There it is. So weird, I wonder why it doesn't work every time. So 4 bits per pixel, 16 colors. I mean, this looks like a really good 16 colors. Very, very Amiga-esque when it comes to the way the pixels look. It's odd that it doesn't seem to take up the full screen though. The menu does take up more, but the graphics demos all seem to be running sort of in this letterbox mode. Notice here we got some parallax scrolling going on with the clouds versus this foreground layer. There's this water effect down here as well, and this sort of a copper effect, Amiga copper background. Just all pretty sweet. Nice animation as well with the reflection. Even the warping and the water effect is affecting the reflection as well. That is super cool looking. I'm noticing that all the demos and everything only take up like this much of the screen, at least on this monitor, but this monitor is adjusted, so hooked up to a computer, it definitely takes up much more of the screen than we're getting here. So this top one, red balls, this looks like a game. Worm-like game to show 4 bits per pixel mode capabilities. Let's give that a try. Okay, so this seems to be a large game, so to speak, if this represents how much code space is available. There it is. Just kidding, press any key, okay. All right, I don't have any sound hooked up, so I assume there might be sound. How to play. Okay, gamepad, okay, no, so WASD for moving. F is jump, G is fire. All right, sounds good to me. Let's try it. Oh, what happened? I pushed a letter and the screen went blank. I'm wondering if this power supply I'm using is not strong enough. It's an Amazon 5 volts, 1 amp power supply, but maybe that's not good enough. Here's one that's a little bit more beefy. It's a 2-port Jobby. Okay, let's see if this works any more reliably. All right, we're on red balls. Okay, so I seem to be controlling this little gentleman here. Whoops. Okay, I don't quite get it. Kill them. Okay, that's jump. So I'm stuck between trees. Now I'm controlling this guy here. Oh, I see. I can blow the trees up. Kill him, yellow. Okay. I'm not doing a good job. Oh no, and it just went black. Why is this happening? Power LED is still on. If I push reset, it does reset. It's kind of odd and annoying that it keeps doing that. Let's try Tetris. So the SD light blinks as it was loading the game there. All right, game is not started. I'm trying to bring down the the selection to start gaming. Okay, so wait a second. Okay, WASD, okay. Okay. Oh, yeah, the controls are a little difficult on the keyboard, I gotta say. Obviously, this is designed for a gamepad. That's cool. The graphics are kind of nice. I like them. Stage clear, press any key. Okay, how do you escape out of this? I'm just pushing all the keys here. So this turns on a preview of your next piece where it's dropping. Let's see what other keys do anything. Oh, that exited the game. Okay, so to move up and down the menu, it's WASD. So music only. I need to plug some speakers in so we can hear this music. There we go. It's Tetris music. So, sound effects. Music and sound effects. Here we go. Let's try this. Okay, I shouldn't have picked sound effects. All right, that's cool. So yeah, that music works, and there's the sound for the startup of the menu there. Fair play race, the race with more love and respect of all. All right, nice color scrolling there. Free race. How to play. All right, WASD again. F is break, G activate bonus. All right, I gotta say, top-down racing with a keyboard, not good. My brain is having issues comprehending. So you can back up, go forward. The controls don't rotate as you turn around. So basically, you have to push forward to accelerate all the time, no matter which way you're facing. Graphics are pretty cool, though. Hey, you know, that was actually decently fun, I must say. All right, so I'm just checking out the troubleshooting section in the little manual that came with this. It's got some pretty good troubleshooting, like power LED on and SD card lit and no audio, stuff to check. VGA signal's no good. Check some of the resistors, check that the 74 ACT chip is okay. So yeah, not too bad, although it doesn't have anything in the troubleshooting for screen goes black randomly, although that hasn't actually happened. So maybe that was just a power problem, because since I switched that power supply happened once and then it hasn't happened anymore. Let's check out the website for the uChip Simple VGA Console. I guess right off the bat, we realize now that VGA console is more like game console and not console as in serial console, which is initially what I thought it was. But yeah, portable DIY open source retro gaming console. So this project was posted here to Crowd Supply for crowdfunding, and I'm not sure, I guess back in December or maybe November. But they funded on December 3rd, and they had a goal of $2,000, and they actually raised $3,700, so 185% funded. That's pretty cool. The kit is still available for pre-order. It's just $30 US, $8 US shipping, and $12 worldwide shipping. So very, very reasonable there. So $38 for those of you in the US. And it ships on February 25th, 2021. So actually, I'm glad to have gotten this video out slightly before the pre-order shipped. I wish they had written on the box that this had something to do with crowdfunding. I think I got it after December 8th, so it was already funded. But I would have tried to put this in a mail call video sooner if I had realized that there was some crowdfunding potential to it. Anyhow, let's jump down to graphics and sound. So 256 on-screen colors at a standard resolution of 320 by 200 at 57 hertz refresh rate. So you might have noticed on the CRT, the scanning of the beam wasn't syncing up with the camera. I keep my camera at 60 frames per second and also a 1/60 of a second shutter speed. So when the shutter speed doesn't match the refresh rate of the CRT, you get that banding. And yeah, you could tell that it was not synced up very, very closely to 60 hertz, hence the 57 hertz. But it can do 400 lines with a pixel ratio of 2:1. It has 4 8-bit PCM sound channels mixed to a single 10-bit mono channel, and I guess 30 kilosamples per second. So that would be 30 kilohertz, I think. Fancy graphics made simple, indeed. We saw what the different graphics mode demos were, and they were pretty impressive. So 8x8 pixel tiled modes with 16 or 256 colors and a 2 bits per pixel bitmap mode that supports 256 on-screen colors by changing the palette every 8 horizontal pixels. Sprites up to 128 pixels in width or height are automatically handled by the graphics engine, so you don't need to join smaller sprites to achieve larger ones. 128 8x8 sprites can be drawn in one 256 color frame if they are 8 pixels aligned. For arbitrary alignment, up to 66 sprites can be displayed in one 256 color frame. Sprites can be flipped or rotated. Also supports partially transparent sprites that can represent explosions, smoke ghosts, and other lighting effects. And there are layers for priorities for sprites and tiles. As we saw in the demos, it has smooth full screen scrolling, which is arbitrary in tiled modes, and the color engine for 16 color mode supports per line changes to the entire palette or any one of the 16 colors. Per line vertical row remapping can be used to produce reflection effects such as water and split and flip screens. Clearly that was going on with that horse demo with that ripple in the water. It must have been shifting the pixels left and right. That's pretty cool. And independent, per line, per tile, horizontal scroll facilitates water distortion effects, parallel, etc. Earlier I pointed out that it had very Amiga-esque graphics, and the Amiga has something called a copper, which I think stands for coprocessor, and it allows the graphics chip to change the color palette, per line. And that's how the Amiga achieves those kind of cool gradient backgrounds and used in a lot of games. And this thing was using that on the horse demo, which is pretty awesome. So this really replicates a lot of the Amiga capabilities. Here's a section called Programming It, and there's a Java uChip game map editor. So this seems to be something to help you design game maps, probably the tile maps, which is very handy. Have you ever wanted to create your own game? It's easy. We developed a comprehensive set of APIs and an editor so you can focus on the art and the C code without having to worry about fiddly USB stuff, VGA signal generation, and other complications. And of course, it's fully open source. Program your game logic in C, and we did the dirty work for you. There is no assembly language required. Of course, there's no assembly language. It's all hidden behind the scenes, running on this microcontroller. That's really sweet. It mentions here that on the main PCB, there is an expansion port that's configurable SPI interface, so you can use it to, say, plug in a NES controller or LEDs or other things with it to work in parallel with your software. Now, one thing people might be wondering is, why have a project like this at all? Because, like it says right here, you could just use a Raspberry Pi. Even the Pi Zero W, super cheap. It's a very powerful graphics engine in there. You could write some pretty great games to run on that thing. But I think there's something to be said about programming games on lower level hardware. It's kind of the reason why the Commander X16 project is interesting to me as well. It's like it has somewhat decent, more modern graphics capabilities, but yet is still limited. So you don't just have unlimited power to do whatever you want and write sloppy code. Now, it does mention right here, this uses a Cortex M0 microcontroller, and it's an Atmel. It's a little tiny chip in there, so it is an ARM core, but it's not super powerful. So yes, programming on this thing would be a fun challenge. Now, I'm no software developer, so I would leave it to other people to come up with amazing things. And this thing is, of course, crowdsourced, and it's not out yet, so that's probably why there isn't really a lot of other software available for it quite yet. But hopefully it's somewhat successful and people buy this and start making some cool software. Here's some technical specifications. So yeah, it's got 32K RAM. It's got some flash memory. This is what's inside the microcontroller, which gets flashed from the SD card when you load up the games. And it's a 48 megahertz ATS-AMD21E18 microcontroller. There is, or there will be, an enclosure for this device as well. There it is. It's kind of cute looking, actually. Maybe they'll release the STL files so anyone can print them like myself who doesn't have the case. So a little bit about ITACA Innovations. Project started by 4 young researchers. The aim of applying academic knowledge of electronics to practical applications. That's pretty cool. They're in Verona. So I will put a link to this crowdfunding website in the description below. So you can pick one of these up yourself and check out their stuff. If you're into open source hardware, this is definitely a very cool little device. But yes, I gotta say, this thing is pretty cool. This definitely works. And if you're interested in buying one of these and making the kit yourself, I'll put a link in the description to these guys so you can make your own thing too. It's probably pretty easy to program and fool around with making some cool graphics and stuff. And it's open source hardware, which is extra awesome. I just can't say enough about that. That's just a great thing. So thank you very much to whoever sent this in. I think it came from this ITACA Innovations out of Italy. So thanks for sending this in. It was definitely a fun little build and a cool little project. And that is gonna be it for this mail call episode. If you liked it, you know what to do. And if you didn't, you know what to do. It's all those YouTube things. And that's gonna be it. So stay healthy, stay safe. I'll see you next time. Goodbye.